Good morning, students. Good morning, learners. So, I'll just wait for a minute to start the class. People who are already there, you can actually write down this formula. You'll save some time. I also have written this to save some time. Yesterday I started this, but due to technical issues, I could not proceed. People who are already there on the chart, kindly write down this. Others, I think they are joining. Let them join. Good morning. Good morning, all of you. Anaru, good morning. Prakriti, Rakshita, Manjushri, Gautam, Karthik Yadav, Mahadeva, Sanjana M. Gowda. Okay. Manasa, good morning. Sagar, good morning. Ravikant, good morning. So people who are already there, please write down this. I'll explain in 2 minutes. Ruchita, good morning. Vijwal, good morning. Bharat Reddy, good morning. Please write down this formula. I'm going to explain in a minute. Okay. Shall we start? Good morning, everybody. Good morning. Let us start. So, Bernoulli's trials. This is the last concept of this chapter, and this is the formula here. Bernoulli has given this kind of formula for special kind of problems. So, this you cannot apply for every problem. Only for special kind of problems you can apply this. So that we'll call it as a if there are certain conditions. Yesterday I said that there are 4 conditions. If any problem satisfies those 4 conditions, then you can apply this formula, Bernoulli's trials. So in real life example, if I want to give the example which is very, very relevant for you people, the CET or NEET exam, what you take, or IIT, these examinations, you know that it is an objective type, yes or no? So if you take CET exam, we'll take for example one subject, typical subject, say maths, you have 60 questions. So 60 questions. I think every subject I've got 60 questions, right? Now, I want to know the probability of getting at least 1 mark or 1 mark without knowing anything, or probability of getting all 60 marks without knowing anything. Is it possible? Theoretically, yes. Because every question has got 4 options. A, B, C, D. Question number 1. So there is a possibility that if your luck is good, whatever you select, it is correct. So like that you have got how many? 60 questions. Every question has got options A, B, C, D. Right? Yes or no? Can somebody guess what is the probability that you get all 60 questions correct? So based on the things what you know, okay, we'll start with one question. I want you people to understand what happens here. If you start with one question, okay, imagine that there is not 60 questions, just one question is there. Then what is the probability that you get correct answer? 1 by 4, because there are 4 options total. Only one is correct. So your probability will be what? 1 by 4. If I had only one question, now imagine I've got 2 questions. Now you tell me, anybody, what is the probability that you get both questions right? That is, you should get 2 marks. You don't know, but you are guessing. What is the probability that you get both the questions correct by guessing? So somebody is giving 1 by 8. Somebody is giving 25. 25 impossible. Somebody is giving 1 by 2. Somebody is giving 2 by 8. All of these things are wrong. Okay? How you get 1 by 8? Okay. Hmm? Yeah, 1 by 16. Yeah, somebody said that. Kritik Goda. 1 by 16. Actually, 1 by 16. Suppose if I have three questions, we will see that how. So if I have three questions, Kritik Goda, can you answer? If I ask three questions now, what is the probability that I would get all the three correct? I want Kritik Goda 1 by 12. Wrong. Wrong. Means the concept is not clear. So that is what we are going to learn today. So actually, if you really want to do, okay, sample space, all of that, it will be very, very tedious process. This one is 1 by 16 is correct. What will be your sample space? Here there are four. First question, you could have answered A, B, C, D. Second question, you could have answered A, B, C, D. All are possible. Similarly, you get A, B, C, D. Similarly, A, B, C, D. Similarly, here, A, B, C, D. Right? So, total 16 is possible with two questions. But only one combination will be correct, right? That is 1 by 16. So, if I take third question, my sample space becomes what? 64. Like that it goes on. If I take one more fourth question, my sample space becomes 64 into 4. Like that it becomes. And if you want to list all these possible outcomes and then look for which combination is correct, it is a time taking process and it is very, very lengthy. For such kind of things, what Bernoulli did, Bernoulli gave a technique. Don't worry about 60 questions. Just bother about only one question. Just bother about just one question. Just one question. Okay. Don't bother about 60. I will take care of that. How to. So what he said is, you bother calculating probability for just one. So everybody said this actually. Most of you people said the correct answer for this. If I had only one question, my probability of getting success, that we call it as P. Here, the condition for Bernoulli's trials, yes, there are four conditions. The first condition is very, very important condition. Your problem, your random experiment, you will make it into two outcomes, dichotomous, that is success, failure. So you will define what is success for you people, and then you tell that, okay, if I get this, this is success. Otherwise, it is failure. And we will give a name for that, that is probability of success, P, letter, symbol. P is probability of success. Q is probability of failure. So every problem will be converted into like this, success or failure, dual outcomes. So, and obviously, probability of success and failure, if you add, you should get 1. So from this, you get one relation, Q is equals to, that is probability of failure is equals to 1 minus P. Okay, this relation also you'll get. And then what is N? Total number of trials. If I take this CET exam, one subject, so total number of questions, what you have got? 60. All the 60 questions you will be attempting, na? So that is number of trials. N. N is number of trials. Now what is this capital X? It's a random variable. So for random variable in Bernoulli's trials, always you assign a single value. That is number of success. Number of successes. So if I take, for example, the CET exam, what is the probability that I get at least one question correct? If I attempt all 60 questions without knowing anything, but what is the probability that I get at least one question correct? At least 5 questions correct, or exactly 5 questions correct, or at most 5 questions correct? So all of that is basically number of successes, your X value. Your X value always will belong to 0 to N. Yes or no? I am performing this exam with 60 questions. So my success maximum could be 60, minimum could be 0. So if you are very unlucky, you try all 60. But if you are unlucky, we may get even 0 also. That is possible, right? Yes or no? So in the worst case, you may get 0. maximum, the best case for this experiment, you will get 60 n, that is number of trials. So x value, number of successes belongs to 0 comma 1 comma 2, maximum up to 1, starting from 0 to n. So now you know this is the formula. This is the formula. This x value, it can be 0 or 1 or 2 or 3, whatever. Okay, capital X equals to x. X will take certain values. The formula is ncx q to the power n minus x p to the power x. Look at this. This looks like your general term in binomial. Yes or no? Binomial theorem. Only thing is n is taken as it is. In place of r, you have got here x. In the formula, you had ncr.